In the summer of 1838, Samuel Burley Rowbotham performed what has become known as the Bedford Level Experiment. Standing in the middle of the Bedford Level Canal with a telescope, he was able to watch a friend row a boat along the length of the perfectly straight canal for 6 miles, where the boat should have been 16 feet below the horizon, thus proving that the Earth is flat. 178 years later, in the summer of 2016, a new generation of flat earthers from the Flat Earth UK group returned to the very same spot to recreate this iconic experiment, but this time with lasers and Nikon FinePix P900 cameras, which seems to be the flat earth camera of choice. All in all, about 50 members of the Flat Earth UK group attended this event. The group met at the Three Pickerels pub for about an hour of some much needed meet and greet time. It's a rather lonely experience to see the world as we do and be surrounded with people who can't. And while it is a relief to connect with others via social media, nothing beats meeting bright, intelligent, like-minded people that you can actually talk to. So, arriving at the bridge at Welsh's Dam, we noted our first potential problem. Out of all the active waterways across the country, it seems that the old Bedford Level had not been maintained, so reeds and lilies had been allowed to overgrow and encroach into the canal from both banks, even into the centre of the canal in some places. But after surveying the stretch through a telescope and the P900s, it appeared there was actually a narrow but clear path to see all the way to Welney Bridge. Murray Ferguson had travelled down from Scotland to provide us with the use of his kayak, and the intrepid Matthew Seddon volunteered to paddle it. And while he got acquainted with the kayak, we set about attaching a high-powered green laser to the back of it. The deck of the kayak was about 8 inches from the water, but it sloped upwards, so we had to use our best judgment to place the laser as level as possible. And with that done, we were ready. The water level was up at 1.2 metres, which was actually higher than the waders we'd brought along. We also had a dry suit that leaked, and since nobody there wanted to sacrifice a tripod to the water, it was decided to film the kayak from the bridge, and I would don the not-so-dry suit, then perhaps take pictures from the water once Matthew had reached the end. Matthew began to paddle towards Welney Bridge, with 3 high-powered cameras with telephoto lenses, a telescope and multiple pairs of eyes trained on him. There was a thrill of excitement when he got about half a mile away when we started seeing flashes of laser light from the back of the kayak. But the excitement soon faded when we realised that the laser must have been angled up towards us. So as he got further away, the laser would point higher and higher into the sky. We could see that there was a bridge about 2.5 miles from us, so we radioed Matthew to meet us at the bridge so we could realign the laser. However, the bridge turned out to be a rail bridge, and we could find no way to reach it by car or by foot. Matthew waited for us at the rendezvous point, but then carried on when we didn't appear. When we arrived back at Welsh's Dam, Matthew had progressed about 4 miles and could no longer be seen by the naked eye. However, he was clearly visible in the camera screens. 500 years ago, observers would claim that they could see ships disappear over the horizon hull first, just as Matthew had done to our naked eyes. However, these ancient observers did not have access to the Nikon FinePix P900, so an enduring myth was dispelled, and that so-called proof of the curvature of the Earth was rendered invalid. This series of time-lapse images, provided by MIT I believe, is therefore a deliberate lie. The weather on the day was rather strange. One moment it was hot and sunny and the next it was raining, but throughout the atmosphere was thick and muggy, and there was a heat haze coming off the water. So under those conditions, we began to lose sight of Matthew's bright orange life jacket and white paddles at about 5.5 miles. When he finally reached Welney Bridge, Matthew began waving the paddle and the laser, which by that time had unfortunately exhausted its battery. Back at Welsh's Dam, I was making a last attempt to find Matthew through the telescope when I caught sight of blurry white flashes, which I took to be the paddles waving back and forth. However, Dave Marsh, who had been operating his Nikon P610 until its battery died, pointed out that it was actually traffic crossing a bridge that he could see in the background for most of the experiment. There was a wave of disappointment until it was realised that the only road bridge on that stretch of canal was in fact Welney Bridge itself, and the cameras could see the cars crossing the bridge 6 miles away throughout the experiment. Although the experiment was a rather ad hoc affair and not performed under ideal conditions, not a hint of curvature was detected. It was a good first attempt, but now that we have seen the terrain, now that the unknowns have become known to us, the next time we'll be better prepared. As a postscript to these results, the trolls and detractors will point out that because we were observing Matthew from the bridge, we wouldn't see the 16 feet of curvature anyway. But I would like to add in some of the latest and very fine work by 𝐺𝐸𝐺, who has correctly pointed out that the calculation of 8 inches per mile squared is actually wrong.
You guys told us that it's 8 inches per mile squared, but that it's only good up to a quarter of the globe. So how can that be the correct formula for the curvature of the entire Earth? If we start at the top, say at the North Pole, and we walk around to the bottom, say the South Pole, we just went over a bunch of curvature. How would we measure that curvature? Now, many people will say you only can do a quarter of the globe because once you get there, you start walking back underneath yourself. Okay, I can see that that's a problem, but why don't we just turn the globe onto its side, lay it on a table, and now we can look at it as a racetrack, as if we're going around a racetrack. So if we look at the green flag there and think of that as the starting line, and we're going around a 25,000 mile racetrack, what is the curvature of the 25,000 mile racetrack? Also, being that we're looking at a perfect circle, shouldn't we be able to chop it up into segments, and by adding the curvature of each segment, we should get the entire curvature for the entire racetrack or circle. So if you see here, we took 25,000 people and put them 1 mile apart, and between each of them, they have to measure the curvature between them. So that would be 8 inches per mile. We don't have to do the squaring since we're measuring each distance. So 8 inches times 25,000 would be 200,000 divided by 12. 16,666 divided by 5280 comes out to 3.16 miles. So Mike, is that what you want me to believe, that there's 3.16 miles of curvature on a ball 25,000 miles around, and by only curving 3.6 miles I will end up back where I started after walking upside down? Let me try and explain what I think the curvature should be. So here you're looking at somebody who just walked from the North Pole to the South Pole. Obviously following the white arrows, he went around the globe, but he is now completely 180 degrees different from when he started. He started standing upright, now he's standing upside down. So an engineer told me if we draw a line from our 2 points on the globe surface, so you'll see I drew one at about 12 o'clock and one about 2 o'clock, and connected those with the line segment A, then the distance between A and the surface, which is marked as line B, would be the curvature. Would you agree with that? If so, then we'll take a new line, we'll call that D, from the North Pole down to the South Pole, and we'll call the line R for the radius going from the middle out to the surface of the globe. So now that would mean that if you walked from the North Pole down to the South Pole, you went over the amount of curvature that is R, which is the radius. Not really sure how this can be disputed. Seems right. You definitely went up and over the 4,000 mile hill, so I could see it being 4,000 miles of curvature in 12,500 miles traveled. Now if we wanted to complete and go through the whole globe, we just continue on our way back up to the other side, and there that means that we went through 7,917 miles of curvature. And so if we wanted to figure out the curvature of the entire ball, we would just do 2 pi r, which equals 24,862. Then take that 7,917 and divide it by the circumference, which is 24,862, and we get 0.318. Let's see if this sounds right. So you'll see I use the red marks to mark off 8 sections of the globe. So it's 8 different sections, so we take 24,862 and divide it by 8, which gives us 3,107. So that's 3,107 miles traveled in between each of the red segments. And if we take that and we multiply it by the 0.318, we get 988. Well, 988 sounds about right for the miles of curvature in each section of 3,107. And if we take that 988 and multiply it back out by the 0.318, of course we get the 7,917, which is the exact diameter of the Earth, which is double the radius, which is the curvature of each half. So when you look at it that way, it starts to make sense. Now we can actually figure out what the curvature of the globe would be, and it is preposterous. Again, it is simply a deception. Math always has formulas that work for whatever they're trying to do, but in this particular case, just measuring the curvature of a circle, there's no way to figure out the curvature of a circle all of a sudden. Now we can only do a quarter of it. I thought math was reality. And I'll leave you with this, why I think it possibly could be the hidden math equation of all time. Why have we never heard about 0.318? Did you know that you can take the circumference of any circle and multiply it by 0.318 to get the radius? Try and find that online. It's that simple. How about 1 divided by 3.14, so 1 divided by pi is 0.318, and 1 divided by 0.318 is pi. Now this works on any circle. If you were to take a 25-foot circle, the amount of curvature is 0.318 feet per foot of circumference.
So, according to this new information, Matthew should have disappeared under 1.7 miles of curvature, not 16 feet. Thanks to Laura Brooker for organising the event, Matthew Seddon for the mammoth task of paddling non-stop for the 6 miles without sticking your tongue out in concentration, Murray Ferguson for the kayak, technical support and willingness to race up and down the Cambridgeshire countryside looking for Matt, and the rest of the Flat Earth UK group who came along to this wonderful and historic event. Thanks to you all.